Hi, welcome to another edition of Admiral Science. I'm your host, Mr. Allen, and today it's all about acids and bases. Alright, so what is an acid? An acid is a substance that produces a hydronium ion in water. Alright, so it produces this H plus here. It produces this H plus in water. Alright, hydronium. Alright, H plus ions in water. And it ranges on the pH scale of 0 to 6. Alright, so from here, these first box is 0, 1, 2, 3, 4, 5, 6. These first 6 boxes represent the acids. And acids taste sour. Alright, they conduct electrical current, and they are very corrosive. They react and destroy body tissue and clothing and other things. And they react very violently with metals. Especially the stronger acids are. The stronger the acid, the worse it acts with metals. Alright, and some of our common acids, your citric fruits like lemons, limes, there are acids, and you have several. You have stomach acids. You have vinegar is an acid, just like right here. This is a jar of vinegar. This is an acid, and so then you have bases, and bases are the substances that produces hydroxide ion or OH negative ions. So one produces H plus, and the other one produces OH negative in water. All right, and why? How is that important to water? Because if you look at the two components, H for acids and OH for bases together, what do they make? Water, H2O. Alright, so and they range on a pH scale of from 7.1 if you go by decimal places, but for case purposes from 8 to 14, or anything greater than 7 to 14. Alright, so and some common bases: baking soda, seawater, milk of magnesia, ammonia, lye. And bases typically they taste bitter, they feel slippery, and they also can conduct an electrical current. Bases are caustic, and that means they can burn or corrode other substances. All right, so and we use bases basically to do our cleaning. All right, because they can clean off. They're a very strong scent in that word. All right, and some of our common bases, as I said before, is cleaning supplies. You got ammonia, you have baking soda, you have oven cleaner, you have Drano. These are all common bases. And because a lot of these things, like your oven and your Drano, which requires you to go through a metal, an acid wouldn't be particularly important in cleaning because acids eat away at a lot of material that bases don't. Alright, so now what happens when you take the two? Well, when you want to raise the pH of an acid or you want to lower the pH of a base, you would simply add the opposite. So let's say, for example, you have an acid and your stomach acid. Your stomach acid has a pH of 1. Alright? And you know that the bases go from 7.1 to 14. You're going to need a base to even out your stomach acid. Let's say your stomach is too acidic. You're going to need a base to even it out. And that's where antacids come from. Antacids are bases, and they're used to raise the pH of an acid. And then you have acids that can lower the pH of a base, because if you want it to be closer to neutral, you'll raise an acid with a base, or you'll lower a base with an acid. So you use the opposite. Alright, so and what happens when you get an acid and a base and you do this neutralization is, for one, it becomes neutral. And then on the other sense, it produces two things. As I said before, water and salt. So salt and water are produced during this chemical reaction. Alright, so on a pH scale, we have acids that go from 0 to 6.9, or 0 to 6, and then you have your bases that go from 8 to 14. Alright, so your common acids, like I said, hydrochloric acid, which is HCl, has a pH of 0. Stomach acid, lemon juice, vinegar, soda, rainwater, milk, things that you would typically eat are acids. Alright, and then you have egg whites, baking soda, antacids, ammonia, quicklime, drain cleaner, lime. These are your bases. Alright, and you notice that I didn't mention 7 because 7 is neutral. 7 is your pure water, pure nothing in it water. Alright, so that's your 7, that's your neutral. Alright, so everything lower than neutral is an acid. Everything greater than neutral is a base. Alright, so here we have some litmus paper, and litmus paper for bases are blue and for acids are red. And if you dip a blue litmus paper into an acid, you'll get red. If you dip a red litmus paper into a base, you'll get blue. Alright, so it'll change the color to what it's supposed to be. So this is bases are blue, B for blue, and acids are red. Alright, so let's play a game of name that substance, acid or base. Alright, so we're going to look and see if we can identify based off of these characteristics which one is acid, which one is the base, and that sort of thing. Alright, so let's see. We have a pH of 6.3, tastes sour, and it turns litmus paper red, or keeps red. So these characteristics will be all examples of what? If you said acid, you are indeed correct. Alright, so for substance B has a pH number of 13. It feels slippery, and it turns litmus paper blue. What would we call that? A base. Alright, then let's look at C. C is neutral 7. It has no taste, and it doesn't really change the litmus paper either or. Alright, so this one would be neutral. It's neither acid nor base. Alright, and then you have this one that says it has a pH of 1. It reacts very violently to metals, and it turns litmus paper red. These are all characteristics of an acid. Alright, so please feel comfortable with knowing the difference between acid and base. Typically, you know that an acid tastes sour, and a base tastes bitter. A base is slippery. Most of your cleaning supplies are bases. Most of the foods you eat contain acids. And that neutral or pure water is neutral, that has a pH of 7. Alright, if there's any questions, please leave them in the comment section below. I look forward to seeing you in class. This has been another edition of Admiral Science. Enjoy your day.